Welcome back, Splunk enthusiasts. This video is brought to you by Lame Creations, log analysis made easy, where we help you master the tools and techniques to become a Splunk pro. In today's session, we're diving into the world of SPL, or Splunk Processing Language, to help you sharpen your skills and become a more powerful data investigator in Splunk. We'll be working with the BOTS version 3 dataset, Boss of the SOC, a realistic, hands-on dataset full of cybersecurity challenges that's perfect for exploring real-world scenarios and honing your search skills. Want to take your Splunk skills to the next level? Learn how to use the Timechart command to visualize data trends over time like a pro. In this tutorial, we break down everything you need to know to create dynamic, time-based visualizations that reveal the hidden stories in your data. What you'll learn how to create time-based charts and trends. You'll learn tips on using time chart options like limit and span. And you'll see real-world examples to help you monitor metrics, spot patterns, and make data-driven decisions. This is perfect for Splunk beginners and veterans looking to sharpen their search skills. Make your data work for you. All right, as always, remember this is the BOTS v3 dataset, so we need to make sure we turn our time to all time to encompass that. And the first thing we're going to do is we're just going to do a count of our events in this data set over time. So we can do index equals bots v3 time chart. And this is going to be used all the time. We can use the span command. It can be 1 day, it can be 1 week, it can be 1 hour, it can be 2 hours, it can be 1 minute, it can be 1 second. I think 1s a second. Anyway, it can be all of those. For this, we're just going to use 1 hour, but if we do it, we can see what comes back. We see each of the times broken up by an hour: 8:20, the 3 o'clock hour, the 4 o'clock hour, the 5 o'clock hour, and all the data is put into those buckets. And then we could make a visualization off of that. The visualization in Timechart does not look good with this data set, primarily because of how old it is. When I go to the visualization, I want a network diagram. If we go with a line chart, for example, problem is the data is so small and it doesn't like to show up. This is a situation of the BOTS v3 dataset, not a limitation of Timechart. And I'll show that by keeping this query alive. We're just going to go index equals underscore internal. And if I run that, and I run this the last 4 hours, we can see it is not a problem filling those things in. It is the BOTS v3 dataset, and it's solely based off the time being so far in the back. There are things we could do to fix it, but for these videos, I apologize. We will not be showing the visualization. And it's kind of funny to do a time chart without a visualization on it, but it's really about the way it breaks things up into chunks, manageable, and why that can be valuable. So anyway, now a cybersecurity analyst might want to know this time chart because they might want to be able to identify anomalous activity patterns. Maybe they want to monitor trends in the logs or investigate time-based attack patterns. Non-cyber individuals be interested because it allows them to analyze systems or application usage trends, monitor operational performance, or support business activity analysis. The next query, we're going to put in our source type equals stream TCP so that we don't search through everything, so we are a little more responsive. And remember, that's our network traffic on the TCP protocol. And we're going to keep this span of 1 hour, but we can put stats commands in here. This is really just a stats command using time. And so, much like we did in stats, where we can get the average bytes, and then we can display it nice with the as command, we're going to use the time chart here, and we're going to span it by 1 hour, and we're going to see them all get chunked up into 1 hour segments of the average bytes. This was the average amount of bytes in each one of these segments. This could be useful for a cybersecurity analyst to detect data exfil or unusual data transfers, identify trends in their network traffic. When are high periods of data going out? When are low periods? Monitor for command and control traffic. Non-cyber individuals might use it to track data usage trends, evaluate system performance and load, or monitor for application efficiency. Next one, we're going to take this source type off, and we're just going to go with status of failure. Just to not look at everything. Time chart 1 hour, count, and we're going to look for login failures. And so I just do And so we're just going to span 1 hour, count as login failures. And we run that. We've changed the count field. This is nothing more than count, but we can see how many login failures we had on our network each hour. Why would a cybersecurity analyst want to know this? Identify brute force or credential attacks, detect unauthorized access attempts, and establish baselines and identify anomalies when it comes to login attempts. Non-cyber individuals are going to want to use that to monitor system or application health, identify user experience issues, and support security awareness initiatives. Here we're going to use the source type equals stream HTTP, which will be our HTTP logs. And what we want to do is we're just going to do count by status. When we do this, we can see all of our HTTP status codes broken down. And so all the zeros, the 200s, 201s, 204s, and these will be the most commonly occurring status codes, and everything else gets lumped into the other. Reasons one might want to do that is to detect anomalous HTTP status codes, identify indicators of potential web exploits, an increase in 4xx client errors or 5xx server errors, monitor for distributed denial of service signs, or a non-cybersecurity analyst could look to see the website health and performance by looking at the error codes, monitor the user experience on the error codes, or identify usage patterns by status. We'll now look into our stream DNS logs, and we're going to be looking for the average response time. Average response time by the source IP. It's going to be seeing how long it takes from a DNS query till it gets its response. Reasons we might want to do that as a cybersecurity analyst is to identify potential DNS tunneling, detect the anomalous DNS behavior, or monitor for performance-related security risks. A non-cyber analyst is going to look for similar things, but they're going to be looking for DNS performance and latency, or identify network bottlenecks or misconfigurations, and then optimize system performance. We're now going to go back to our status of failure. But this time we're going to add a few extra features into this time chart. We're going to keep the span, but we're going to use this limit command. And so we're going to limit how many results we get back. Here we've been getting 10 results. And then the other field, we can now use limit equals 5. That will give me back 5 responses, and then the other and all the nulls. One last thing, this is going to make our system very unhappy. But if I want to, we can, I lowered it. I could go 11 and bring it back 11. Or I can do limit equals 0, and there will be no other field anymore. It's going to show me every user account. Just throwing that out there in case you wanted to know how to get past the limitations. We might use this query to look for users over the user accounts that had failures. Remember, that's what we're seeing here. They're static. Which users are having failures? We might do this to detect account-based brute force attacks, to identify compromised accounts, or establish patterns of unauthorized access attempts. Non-cyber analysts could use this to identify user experience issues with authentication, monitor usage trends for system access, or support audits and compliance reporting. We're going to now use one more just to kind of show the concept again. Respan equals 1 hour, sum of the bytes by dest IP. Just going to show, again, more just simple, never forget you can do all those calculations and get back sum, mean, median, mode, all of that. Back we get, it's going to give us the bytes. Why might we use this? To identify unusual data transfers or exfiltration attempts. Here, we're going to actually get back the systems that have, because it's taking the 10, it's going to be the top 10, the largest systems of bytes out. So we could be looking for exfiltration attempts, monitor for potentially malicious external communications, or track bandwidth usage by IP for threat hunting. A non-cyber analyst could be using this to monitor network bandwidth usage, identify resource usage patterns, or optimize data routing and load balancing. Here's another unique way of looking at stuff. We can go here with the distinct count user and use that in our time chart. And this will tell us how many unique users we have on the network in any given time chunk. Kind of a nice little peripheral here. And we can use that to detect unusual account access patterns, identify potential account compromise, or track trends in system access for threat hunting. Why a non-cybersecurity analyst would use this? To monitor user engagement and access trends, assess system performance and load capacity, and support audit and compliance reporting again. Here's another. This query here, we're going to do count by severity. And when we do the severity, we can actually see the alerts coming back, how many highs are coming back each hour, how many informational, and how many mediums. Useful to monitor and prioritize threat levels, detect anomalies in severity trends, or evaluate the effectiveness of your security measures. Non-cyber analysts could use that to understand system health and event trends, assist with resource allocation for system management, or help support compliance and reporting. This last query, we're going to do the source type equals stream HTTP. Again, we're going to look at the web logs, and we're just going to look at the 404 errors. And we're then going to go chat count, and we're going to rename it as HTTP 404 errors. So we can actually see how many 404 errors are occurring in each of those time chunks. Definitely, you can see an outlier right there. We can use that to identify potential reconnaissance or scanning activity Monitor for signs of web application attacks, or investigate anomalous user behavior. Non-cyber analysts might use this to improve user experience by identifying broken links, monitor web performance, or support analytics on user navigation. That's our quick summary on the Timechart. Hope it was helpful. Thanks for tuning in to Lame Creations, log analysis made easy. If you found today's video helpful, don't forget to like and subscribe so you never miss out on the latest tips, tools, and tutorials to boost your log analysis skills. Want to take it a step further? Become a member to support the channel and gain exclusive early access to videos and exclusive focused training. Join us on Discord where we dive even deeper, share insights, and tackle questions together. Until next time, from Lame Creations, where we help you go from being a lame analyst to a Splunk ninja.